Okay, in this question here, we have a quadrant 3 point, -2 and -5. Let's just sketch that. So the point here, -2 and -5, maybe like right there-ish. -2 and -5. So I always connect that to the center, the origin, and I drop a perpendicular line always to the x-axis. Let's label what we have. Along the x-axis, we have -2. Along the y-axis, we have -5. Now we want to sketch this angle and we want to determine all of the values of all six trig ratios. So before I can do that, I need to use Pythagorean theorem to come up with my radius or my hypotenuse length. So I'm going to do x squared plus y squared is equal to r squared, or a squared plus b squared equals c squared. So this is going to be 4 plus 25 equals r squared. So 29 is r squared, so r is going to be plus or minus the root of 29, but the radius and the hypotenuse are only positive, so the radius is square root 29. Okay, so now that I know that the radius is square root 29, I'll just label that on my triangle. I can now find all of the ratios, okay? So let's start with sine. So sine of theta is y over r, or opposite over hypotenuse. So that's -5 over root 29. And of course, I'm going to rationalize my denominator by multiplying top and bottom by root 29 to get -5 root 29 over 29. Now, if that's sine, what goes with sine, the reciprocal of that is cosecant, which will be, flip it around, but keep the negative on top, root 29 over 5. Okay, cosine. Cosine is equal to x over r, or adjacent over hypotenuse. Of course, I need to rationalize that by multiplying top and bottom by root 29. And the reciprocal of cosine is secant. So if I take cosine and I flip it, it's going to be root 29 over 2, and then keep the negative on top. Okay, we have to do now tangent and cotangent. So let me give myself a little bit of room here. So tangent is y over x, or opposite over hypotenuse if you prefer. So tangent is going to be -5 over -2, which in lowest terms is 5 over 2. And cotan is going to be the reciprocal of that. So just take 5 over 2, flip it, and you get 2 over 5. Now, the last thing you want to do is find the angle in radians. So to start that, I'm going to find the reference angle first. So to find out the reference angle, I want to go to one of the ratios that is positive, for example, tan of theta. And since I want the angle, I need to use an inverse function. So tan inverse of 5 divided by 2. That is going to give me my angle, and I want to be in radians. So let's just make sure we are in radians. Yes. So we're going to do tan inverse, and then that was 5 over 2. So 5 divided by 2. So my reference angle is approximately 1.2 radians. So my reference angle, approximately 1.2 radians. Now you can leave it like that. In the absence of a degree symbol, it is radians, or you can actually write it out. Now that's my reference angle. So right in here is 1.2 radians. But what I want to know is the measure of that angle from 0. So that means from here all the way to this point, which is pi plus a little bit more. So my angle is going to be pi plus my reference angle. So let's figure out what that is, and we want to the nearest tenth. So I'm going to do pi plus my reference angle. So I'm going to go pi, and then I'm going to add that to my reference angle. And to the nearest tenth, I get that the angle is about 4.3. So then I'll say that theta is about 4.3. Again, you can leave it like that, or you could write out radians if you prefer. But in the absence of a degree symbol, it will always be in radians.